Hello? What's up, chat? What's up, chat? Uh-oh. Uh-oh, guys. I guess I didn't set up my webcam today. That's my bad. Um, I guess no webcam for today. Where is this? Yeah, no webcam for today. Um, that's my bad. Yeah, that's my bad. Uh, 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 uh. Gonna continue this Arduino student kit. Oops. Well, don't need to read that. Look at your project board. Let me actually... Oh, that's why. I guess let me just remove this. Wait a minute, what is recording me? Is OBS still using my camera even though I turned it off? That's crazy. Well, I guess there's no cam today, guys. No, whoever, no one's watching. Well, whatever. All right.
Measuring electricity. Electricity can be thought of as the flow of electrons through a conductive path. One way to measure electricity is by electric current. The current in a river is the amount of water flowing past a certain point in the river over a certain time. In the same way, Electric current is the number of electrons flowing through a certain section of a conductive path in a certain time. Current is measured in amperes, or amps for short. 1 amp is equal to about 6,241,500,000,000,000,000 electrons flowing past a point in 1 second. Another common electrical measurement is voltage. Voltage is a difference in electrical energy between 2 points. It is a comparison of the number of electrons at one place versus another. One way you can think of voltage is as pressure that pushes electrons through a circuit. The more electrons, the more pressure and the more voltage. The unit for measuring voltage is the volt. A standard AA battery has a voltage of 1.5 volts between its two ends. A standard wall outlet has a voltage of about 120 volts in the United States and 220 volts in most European, Asian, and African countries. Resistance is another common electrical measurement. Resistance is just what it sounds like, a measure of how a material resists the flow of electrons. Good insulators such as plastic, rubber, and glass have very high resistance, slowing the flow of electrons. Good conductors such as metal have very low resistance and allow electrons to easily flow. Resistance is measured in ohms. The Greek symbol omega is often used to symbolize resistance in ohms. Conductance is a measure of how well a material allows electricity to flow through it. It is the opposite of resistance. If a material has a high conductance, it has a low resistance. Materials that have a high resistance have a low conductance. This is called an inverse relationship. Conductance is measured in Siemens.
It's conducted in what now? High conductance, low resistance, low conductance, high resistance. I thought water would be more high, more conductible. That'd be have a higher conductance. But it's still a good amount, but it's not that much. Let's fire a Mo. Mo.
Note, in the past, the unit for measuring conductance was the mho ohm spelled backward. The mho was an indication of the inverse relationship between conductance and resistance, measured in ohms. George Simon Ohm is credited with discovering the relationship between voltage, current, and resistance. In a paper he published in 1827, he wrote about how the current in a circuit is proportional to the voltage pushing the electrons through the circuit. This discovery is called Ohm's law and can be written in the form Voltage equals current resistance. Or V equals
Revere.
IR.
V equals
Note,
IR. Yo.
variables are letters or symbols that
I
represent a
remember that.
certain quantity in an equation. For Ohm's law, V is used to represent voltage. The letter I is used to represent current. For resistance, the letter R is used. Using algebra, you can rearrange this equation to solve for current or resistance. Current equals voltage slash resistance, or I equals V slash R. Resistance equals voltage slash current, or R equals V slash I. In a later lesson, you'll do an experiment to prove Ohm's law. 2. Locate a 560 ohm resistor. It should look like one of these two pictures.
Let me. You guys can't see it, but I'm taking it out, bro. Yeah. Brown, blue, green. Yep, I found it.
Note, your kit should have one type of resistor or the other, but it should not have both.
Have this one.
Resistors usually have two wire leads, one in each end. Electricity can flow either direction through a resistor, which means that resistors can face either direction in a circuit. A resistor is an electrical component that resists the flow of electrons and helps control the amount of current flowing through the circuit.
Fire.
Resistors work by converting certain amounts of electrical energy to heat by creating resistance in the circuit. Resistors usually have two wire leads, one in each end. Electricity can flow either direction through a resistor, which means that resistors can face either direction in a circuit. The value of a resistor indicates how much resistance will be added to the circuit. Recall that resistance is measured in ohms. A 220 ohm resistor will add 220 ohms of resistance to the circuit. A 10 megohm resistor will add 10 million ohms of resistance to a circuit. The table here shows some of the common prefixes used in electrical measurements as well as their values.
A pico, a nano, a micro, a milli, a kilo, a mega. Mega. Million. Trillionth. Billionth. Millionth. Thousandth. Thousand. Million. Oh, they actually mean something. I did not know that.
Notice the color bands on your 560 ohm resistor. Resistors are usually marked with either 4 or 5 color bands. These bands indicate resistance. Each color represents a different value. This chart indicates what each color represents. Notice that the multiplier is written in scientific notation. The exponent shows how many zeros to add after the digits from the other bands. For example, the 4-band resistor shown at the top of the chart starts with a brown band. Brown has a value of 1, so the resistor's value starts with 1. The second digit is black, so the next digit is 0. The multiplier band is orange, which has a value of 3. This means we add 3 zeros. This gives a total resistance of 10,000 ohms, or 10 kiloohms.
first digit, second digit, third digit. How do you know? So if it only has 4, you know that it's only 2. But if it has 5, it has 3 digits. Then the multiplier, then the tolerance. I see. Okay. Okay, that's cool. That's sick. No two resistors are the same. The tolerance band indicates the position of the resistor. The 10 kilo ohm resistor is the example in the example has a tolerance of plus minus 5%. 5% of 10,000 is 500. So the actual resistance of the resistor can be anywhere from 9,500 to 10,500 ohms. Yeah, yeah. The chart below, the chart shown here represents the resistors that come in your kit. Your kit might have a mix of 4-band resistors and 5-band resistors. However, for each resistor value, you will have only one type, either 4-band or 5-band resistors, not both. So you have this. So I have this one. The blue ones I have are, what color is that? It's maroon at the end. Two blacks, a red, I think. So it's this one. I have this one where it's a yellow at the end, a blue and a red, and gold. That's not on here. Holy, one of my resistors is bent to hell. A lot of my parts, you could hear that, are really bent. Or a few, not a lot, but like a few. Which I don't think is a good thing. To be fair, it has been a long time since I've done, or since I've opened this.
Your 560 ohm resistor should start with a green band because 5 is represented by green. The second digit is 6, which is blue. To get from 56 to 560, we need to add 1 0 to the value, so the multiplier should be brown for 1. A 560 ohm resistor with a tolerance of 5% should have a 4-band color scheme of green, blue, brown, and gold. Its 5-band color scheme should be green, blue, black, black for the multiplier, and gold. Determining the resistance of a resistor from its color bands can be a little tricky at first. The resources section of this course includes a resistor chart that you can use anytime to help you identify resistors by their bands.
Fire.
This chart and a table of resistors included in your kit is also provided in the end of lesson 2. You are welcome to print as many as you want.
I recommend you to complete the resistor wheels activity that is inside your resource tab below. These are tools to collect bits of a resistor. Oh. Oh, so it doesn't matter if I bend them. Okay, cool. Green. It's so, I don't want to do this yet. I'm just gonna read over it and then I'll do it tomorrow. Bend the resistors so they face the same direction. Insert one of the wires. Insert one wire from your into the top hole of the positive. Check the wire. I would do this, but I would want my cam on, so I'll just save this for tomorrow. Insert another wire from your LED. A diode is a polarized electrical device. That means it allows electricity to flow in only one direction. If you look closely, inside the yellow LED part, inside the yellow part of the LED, you'll notice that there is a gap between the two metal plates. Wires. The electrons jump over this gap. Protons, particles of light, are emitted, but electrons can jump this gap in only one direction. Anode and cathode.
LEDs come in different shapes, sizes, and colors. In the activity in the introduction, you caused the built-in LED on the Arduino Uno R3 board to blink. Although that LED is much smaller and a different shape than the LEDs in your kit, it works the same way. The LEDs in your kit have two wires, one short and one long. The long wire is called the anode, and the short wire is called the cathode. On some LEDs, the cathode side of the LED has a flat edge. Current must enter the LED through the anode and exit through the cathode. Therefore, the anode should be toward the positive terminal of the breadboard, and the cathode should be toward to ground.
Really? 1A and 1E? I thought it was only like this.
9. Locate a jumper wire. Your kit contains several different lengths and colors of jumper wires. All these jumper wires work exactly the same. The different lengths and colors are provided to help you organize your breadboard and keep it clean. Most jumper wires consist of two parts: an interior metal wire that conducts electricity and an outside plastic coating that insulates the wire. This insulation has a very high resistance and keeps the conductive wires from touching.
Shoot, I low-key spaced out.
9. Locate a jumper wire. Your kit contains several different lengths and colors of jumper wires. All these jumper wires work exactly the same. The different lengths and colors are provided to help you organize your breadboard and keep it clean. Most jumper wires consist of two parts: an interior metal wire that conducts electricity and an outside plastic coating that insulates the wire. This insulation has a very high resistance and keeps the conductive wires from touching.
Okay.
A. Metal conductor low resistance. B. Plastic insulator high resistance. You can use any length or color of jumper wire. However, it is a good practice to use as short a wire as possible to keep your breadboard looking neat and clean. The pictures shown here use a short black jumper wire. You can also use different colors of wires to represent different parts of the circuit.
Where are my jumper wires? Oh, it's just these, I see. Okay. 1G to the breadboard disconnects. Okay. 1G onto the breadboard disconnects the jumper wire to the LED. There is no F. Oh, F. Set the other end of the jumper wire to the battery.
A battery is a type of electrical device called a power source.
Yes, I know.
Power sources provide electrical current that can be used in a circuit. Besides providing current to a circuit, batteries also store energy that can be used to push the current through a circuit. A battery uses a chemical reaction to supply electric potential energy. Potential energy just means that the energy is stored for later use. Other types of power sources convert energy from one form into electric potential energy. For example, hydroelectric dams convert water pressure, wind turbines convert wind energy, and solar panels convert sunlight into electric potential energy. Voltage is the measure of potential energy. To be more specific, voltage is a measure of the difference in electric potential energy between 2 points. For a battery, those 2 points are the battery terminals. A battery has 2 terminals, a positive terminal and a negative terminal. The terminals are marked on the battery with a plus sign and 8 sign. The battery you'll use has an electric potential of about 9 volts.
Shoot. I'm getting tired.
A battery is a type of electrical device called a
That
power
much more.
source. Power sources provide electrical current that can be used in a circuit. Besides providing current to a circuit, batteries also store energy that can be used to push the current through a circuit. A battery uses a chemical reaction to supply electric potential energy. Potential energy just means
Oh,
that the energy is stored for later use.
my phone
Other
fell.
types of power sources convert energy from one form into electric potential energy. For example, hydroelectric dams convert water pressure, wind turbines convert wind energy, and solar panels convert sunlight into electric potential energy. Voltage is the measure of potential energy. To be more specific, voltage is a measure of the difference in electric potential energy between 2 points. For a battery, those 2 points are the battery terminals. A battery has 2 terminals, a positive terminal and a negative terminal. The terminals are marked on the battery with a plus sign and 8 sign. The battery you'll use has an electric potential of about 9 volts.
Oh, I didn't know this is how it's stacked. It's negative to positive, then from positive to negative. Didn't know that's how they were stacked. Interesting.
The negative terminal of the battery is full of electrons that want to repel each other. The electrons are attracted by the positive side of the battery. So, when there is a conductive path between the negative and positive terminals, electrons flow out of the negative terminal and into the positive terminal. However, there is a danger in directly connecting the positive and negative terminals of a battery. This is called a short circuit. Short circuits create a lot of heat because there are no components to transform the electricity into light, sound, or other forms of energy. Short circuits are harmful for the battery and could potentially burn you or even start a fire. When wiring a circuit, you should avoid creating short circuits. Always include a component that uses current such as an LED, resistor, or motor.
That makes sense.
Electrons flow from negative to positive. But before electricity was fully understood, scientists such as Ben Franklin thought the positive charges moved through the circuit to create current. This is known as the conventional approach to current flow. In this approach, current flows from positive to negative. This conventional approach is still used today by most of the world. All electronic components are manufactured with the conventional approach in mind. So, in a circuit, current flows from positive to negative, even though the electrons actually flow the other way.
Hmm. In a circuit, the current flows from positive to negative. Oh, so even though direction of a conventional current, even though that goes from positive to negative, electrons go from negative to positive. I see. There are two types of current produced by electrical sources. There are two types of current produced by electrical sources: alternating current (AC) and direct current (DC). Batteries are batteries are DC sources. In circuits with DC power sources, the current flows in one position, positive to negative. Um, Alternating current. Oh, I see.
Microcontrollers such as the one on your Arduino Uno R3 board also provide direct current. Each pin on an Arduino board can send up to 40 milliamps of direct current at up to 5 volts. With AC sources, the direction of current flow changes back and forth. As the current changes direction, the voltage in the circuit reverses, forcing the current to flow the other way. Most homes and buildings are powered by AC circuits. For example, the electricity coming from a wall outlet in an American home changes direction 60 times in 1 second. In most European homes, it changes direction 50 times per second. There are advantages and disadvantages to using AC and DC circuits. You can read more about AC versus DC in the Invention Spotlight section of this lesson.
Oh, I could have just read here.
Notice that the battery snap will attach to the battery only one way. The large terminal of the battery must connect to the small terminal of the snap. With the snap in place, the red wire will be connected to the positive terminal of the battery and the black wire will be connected to ground. 14. Insert the red wire from the battery snap into one of the positive holes on the left side of the breadboard. Because all the positive holes are connected on one side of the breadboard, it doesn't matter which hole you use. 15. To complete the circuit, insert the black wire from the battery snap into one of the negative holes on the right side of the breadboard. Because all the negative holes are connected on one side of the breadboard, it doesn't matter which hole you use. The LED should now be lit. Safety. When you are connecting a source like a battery, it is a good safety practice to attach the positive terminal to the circuit first and then attach the negative terminal. When you are disconnecting a source, disconnect the negative wire first followed by the positive terminal. This will eliminate the possibility of a short circuit. The sources used in this course have low voltage and current, so there is no risk of shock or harm to you. However, if you ever change out a car battery, repair an electrical socket, or work with higher voltages and currents, following good safety practices can keep you from harm.
Red then black.
16. With the circuit complete and the LED lit, follow the flow of current around the circuit. Current flows out of the positive terminal of the battery, through the red wire to the positive connections on the breadboard. From here the current flows through the resistor, through the LED, and then through the jumper wire over to the negative holes of the breadboard. Finally, the current flows through the black wire to the ground terminal of the battery.
With the current flowing, your circuit is considered a closed circuit. If you remove a wire from the breadboard, you should notice the LED turns off. The LED turns off because the current has stopped flowing. This circuit is considered an open circuit. Closed circuit, open circuit. Think about the circuits shown here. Which circuit is a short circuit? Which circuit is an open circuit? Which circuit is a closed circuit? What makes each of the circuits open, closed, or short? This is a closed, this is open, this is a short, because like, why is it going like that? Because it's going from the positive to the negative with nothing in between. Okay, it's been 44 minutes. So I'm gonna stop my stream here. Tomorrow I will set up my camera properly, and then I don't have to read this anymore. Because now I have the context, I just need to do the experiment and it will all be good. Alright guys, sorry for the infrequent streams. Stuff has been happening in my life. On the weekends I probably will stream less. Like I probably won't stream on weekends, like Friday to Sunday, because I usually have stuff that I'm doing on those days. But yeah, thank you for watching my stream. Whoever's watching, probably, or actually just nobody's watching my stream, and that's okay. I'm not streaming this for anybody, just for myself, documenting, making sure I actually do this, because if I didn't stream right now, I probably would be doom scrolling. So yeah, all right. But I'm feeling kind of tired. I'm just gonna go to sleep, and I will see you guys tomorrow. All right. See ya.